what are all the things that we need to do in implementing secure network lessons and all. Okay, so really what we're going to do in implementing secure network designs, what is it actually? The objectives are, we'll be learning here what are all the necessary implementation that we need to make on network by securing network designs, routing and switching, wireless infrastructure, and load balancers. These are all the things we're going to discuss in this module. So in secure network design, what problems can arise in a network design or architecture? Okay, so when someone trying to connect, okay, in a business flow, within the properties of confidentiality, integrity, and availability, when they are looking for this, definitely there will be weaknesses in the network architecture. Okay, that is very undetectable. It's very stealthy. Okay, it's very difficult to find. So the typical weakness, such as single point of failure. What is that? Relying on single hardware, server, or appliances, or a network channel. That's what single point of failure. We don't have backup system or like that. And complex dependencies. That is the service that requires many different systems to be available. Okay, 1 or 2, 3, 4. So dependency levels, if dependency levels are more, if it is depending on more different systems to be, it needs to be available. So that is complex dependencies. And availability over confidentiality and integrity. Okay, why? Compromising the security will be like, you will get, for example, you need a service and you need it readily, but you can make it available, but you have to consider about the confidentiality and the integrity of the data and assets that you deal with for long term. And otherwise it will create an issue, or you will not be getting fixed also quickly for that. Okay. And what about lack of documentation and change control? Yes, network design is not only about the devices, it is about how we manage the whole network. So we have the appliances, we have the services running on it, and we have segments also, network segments also. So without proper control, without proper documentation or configuration, change control, so it would be a problem. Okay. And the over dependence on perimeter security. What is that? Like we have a high class, or a very expensive good firewall is there. Okay. Or IDS is there, so that is enough? No, because we depending on only on the perimeter security is not enough, because we have to take care of the host also, each and every network node. Okay. So best practices for having a strong network design is this Cisco safe architecture, which explains you everything and each and every node's places in the network. Okay, so you can go for it. There is a link also, I'll share it. I have it with me, I'll give it to you. Okay. And we have business workflows and network architecture. What is this? Yes, in corporate, it is the network is very essential to support our business workflow, and the decision that need to be made in analyzing that workflow is very important. How are we going to access something, and how the email box server, for an example, mail transfer server, how it's working, and what about segmentation, what is data flows and access controls. These are very important and very important points to be considered, in network infrastructure. Okay, that helps the business workflow with the security. Okay, so access, the client must access the network. That's the first point, by obtaining a physical channel or logical address, right? And he needs to get authorized or authenticated. Without username or password, or without proper permission, that he cannot do it, right? So that is what in the previous lessons we have learned, and he will be getting that in here. He need access in the corporate network. Then email mailbox server. What is that? That ensures that it is only accessed by the authorized clients or not, based on the access. Okay. And mail transfer server. What is that? See, mail transfer server needs to connect with untrusted host only. Like, we don't have idea in case if you have the mail transfer server inside your network. So many people will connect to that particular mail transfer server. Between the untrusted network, you will have the connections in your LAN. So you have to trust that connections also. It has to be properly controlled in the corporate network. So these things will happen. Okay. Next, segmentation. Okay. So when you do carry out such kind of business where you have traffic from uncontrolled networks, outside networks, so we have to do segmentation. Otherwise, it will be a big problem. Okay. So network segmentation is mandatory. Otherwise, it will introduce lots of vulnerabilities. And to analyze the network flow, how datas are flowing and where it's happening. For example, if you're finding out vulnerability in a network architecture, how we can do it by doing proper continuous analysis on data flows and access controls. We'll get to know how or where the vulnerability relies on and how we're going to take effective steps for it. Okay, that's why. Now we have network appliances. Yes, that for building a network architecture, robust network architecture, we would be needing appliances, right? So there are various network appliances according to the OSI layer. We have OSI model, right? 7 layers are there. So at top application layer, we have the server running with the 515 support, some domain names. So these are all the protocols that runs on the layer number 7. Okay. And in the transport layer, we have the load balancers firewall, and it is having a transport control protocol, means you have TCP or UDP to decide there. And on the router level, that works on the layer 3 network level, where you'll get IP address subnetting happens over there with IP. Then in data link layer, where you have the MAC address, everything is happening, where you have switch and access point. Then you will have the physical layer, that is your Wi-Fi or Ethernet cable, whatever. Okay, so that is how your network appliances work in various levels. Okay, with the network appliances. So this is according to the OSI model. Hope you are aware of what is OSI model is. Okay, it's a very basic one, right? Then we have routing and switching protocols also. When we have architecture, network architecture, we will be having routing and switching protocols. We will be transferring packets. The traffic will flow from one node to another. Number of routings will happen. Switching protocols will be in play, right? So we have layer 2 forwarding and layer 3 forwarding. What is this layer 2 forwarding and layer 3 forwarding is? This layer 2 forwarding occurs between the nodes on the same local network segment, okay, that are in the same broadcast domain. Okay, either all the nodes we have in the same segment connected to the same physical unmanaged switch. That's the thing here. Layer 2 will be having unmanaged switch or all the nodes within the same VLAN. Okay, or a single subnet, you can say. Okay, so if you have actually VLAN, it will be a managed switch. Okay, so if you don't have a VLANs, proper VLANs and all, so that would be an unmanaged switch. Okay, then we have layer 3 forwarding. That is, you can say, routing that occurs between logical or physical networks. Okay, a single network can be divided into multiple logical broadcasts. Okay, or subnetted. This will happen like a forward, like in a managed kind of managed switch scenario. Okay, multiple networks will be there joined by the routers, and it forms an internet network, and your forwarding of packets will happen. Layer 2 happens in the local network. Layer 3 happens between your local and the remote network. Okay. Then we have address resolution protocol. What is ARP? This ARP maps your network interface hardware address, that is your MAC address, okay, with the IP address. Okay, normally when a device is connected, that needs to send a packet to an IP address. Okay, and because how any of the devices that is connected in the same network, how it will get introduced, okay, with the switch or with the other devices, it's all because of the address resolution protocol. Okay, then we have IP address internet protocol. We have here IPv4 and IPv6. We know that IPv4 and IPv6. Then we have network prefix and subnet mask. Yes. So we should have a subnet for a managed network, and the subnet mask is needed for that. And the network prefix, that is, I think I will just type the example in here. Okay, so this will be your network prefix 24, 16 or 8, whatever. Okay, C class, B class, A class, it goes respectively. Okay, this network prefix easily helps you understand what is your subnet mask is. Okay, then routing protocols that we know to communicate routing table updates and everything that happens in the network. Okay, then we have network segmentation. Yes, nodes can communicate at layer 2 that we have discussed within the same broadcast domain, but we need to implement network segments to separate unmanaged switches and the managed switches. We need to configure virtual LANs on the managed switches. Okay, so we have to map the subnets to VLANs properly. Okay, why? If we don't have the managed network, anyone can communicate with any other departments. So the traffic will flow here and there. The traffic won't be the managed one. Okay. And it will not be a stable, secure network architecture. To restrict the communication between two segments, we need to go for LANs sorry, subnets and VLANs. Okay, we have to in the segmentation, it's most likely to enforce virtual LANs and subnets. Okay, then we have the topologies. Yes, so when we go for segmentation, we would be following the topologies also, physical and logical topologies. That zones represents the isolated segments for host. Simply, what are the zones are? We have intranet, internet, and extranet. Like, right? I think on the first class, I explained you about intranet and internet. I'll explain you about extranet here. So the traffic between the zones is subjected to filtered by a firewall. Maybe or may not be. Okay, that's not mandatory that you should have a firewall in the middle. You can use it or you don't have to, based on the traffic that you deal with or based on the conversation that's happening between two zones. So here, let me tell you what is zones are. Okay, so we have these three zones: intranet, extranet, internet. Intranet is private only for us. Okay, very limited. Internet is public, where you deal with outside network also. And extranet is partial. Okay, where few clients or few customers will try to communicate with you inside your network. Okay, so intranet is the secure one. No question about that, because we all deal with inside. Still, it is not a secure one. That is why we go for subnetting and all. Okay, that I don't want my department to talk with the other department, other team. Okay, and if there will be a zone such as like there won't be any restriction that they can communicate with the internet or anything. Okay, and what about extranet is partial connection that few people can connect with you and they don't have to. So one of the real example is the mail servers. Okay, if I have a company and I have a database and I have a mail server with me, okay, then mail server is in direct communication with the customers and clients. So daily the people log in and they do mails and they do retract whatever they want to do with that, they are doing. So it is coming under extranet, but there is a small security issue there, that how we are going to address this part, because there are chances that anyone coming into the network, so they can do pivot and they can access my asset also, right? So that is why we have demilitarized zones. Okay, so what is this demilitarized zones are? We have this demilitarized zone. I have the diagram also. Okay, this big diagram. Now I'm going to show you a simple diagram from my side, how this demilitarized zone is working. Then you'll understand. So you don't have to confuse much. Okay. Okay, this is internet. Okay, this is internet. People start connecting and they will do come through your firewall. You have a firewall also, and the firewall is having the rule set it that it is allowing the traffic inside your network. Okay, and this is your database, your personal or your own asset for your organization or anything. Okay, this is your okay, we'll just have it as inverted. That would be easy. This is database and this is mail server. Database and web server, which okay, so okay, so people who tries to connect to my network, they will come inside the mail server and they will take something, they will do their work. But if any malicious user get to know that I'm all having in the same network, so what he'll do, he'll simply try to access my database and web server also. Okay, So I don't want this thing to happen. So what I'm going to do, I'm going to remove this mail server from my network and I'm going to place it inside the DMZ network. Okay, DMZ zone. So how I can do it? Very simply, I'll just open a new, no, we'll just don't have to open a new one. Okay, I'll just remove that particular mail server and I'll place it outside the network. I'll place it outside the network and I will add another firewall just before it. Okay. So what will happen? This zone is what called as demilitarized zone. This zone is what called as demilitarized zone, DMZ zone. Okay. So if anyone tries to access my network, they have to bypass 2 firewalls in order to get into my internal network. So when you have extranet situation, means you have clients or someone who's having contact with you, with your internal network or with your assets. So you can use DMZ zone by placing the important server outside of your network with 2 firewalls. That's necessary. So then only you can have the screening. Okay. The choke router is called as like the firewall or the router that is facing in here, inside towards your internal network. Okay. That is what DMZ zone is. Okay. Okay. So we have the screen host. What is the screen host? How it will work? It's very simple that we do use daily if we have a firewall in our home or in our organization, very small level organization. When you have that single firewall, that's what called a screen host. When your local network is screened by a single firewall. Okay. So this Soho router configuration, actually it acts as both router as well as firewall. This from a brand Soho. Okay. So it is actually not exactly the DMZ. Okay. It is protecting a single local network. There won't be having any other resource that you can have access, but this router firewall will be placed in the same line with your local network also. Okay, this is what called a screen host. Just you're screening away your hosts and the local network by using a single router firewall. Okay, so it's not a big configuration at all with the screen host. This is the normal architecture. Okay. And we have the implications that we have it with IPv6. Okay. Yes, still, we are still using IPv4 more. We are not fully used to IPv6, and we have lots of, if in case you have the IPv6 and you are not handling properly, so we have lots of issues. So what are all those? Enabled by default configuration issues. Okay. And unmanaged configuration. People are not there like who can work on IPv6 and IPv6 specific attack vectors. Okay. And mapping of this IPv6 address space to appropriate security zones. Okay. And configuring IPv6 firewall rules. So it is a very complicated process with IPv6 when we are going to implement. But the future is with IPv6 only. We have to start switching from IPv4 to v6, not only with IP, with the configuration and everything. And typically, there won't be any necessary for address translation. That's the one good news that we have, that we won't be having any public IP, private IP, everything. So everything will be public, but you'll have more number of IP address, but if attackers come to know that, we have some advantages with the private IP, that it is not easy to hack an internal network. But if every node and everything got translated or got transited to IPv6, each everyone will be using a individual public IP. So we all are in the open world. There are lots of security issues may arise with IPv6. It will happen. It will be a big issue then. Okay, so we have this other secure network design consideration as well, where we have data center, cloud design requirements also. So how this, for example, if there is a cloud network or data center, how the traffic goes or how the network design should be made. Okay, so that they've mentioned in here. The traffic should go from east to west. That is, in the data center, traffic should enter from north to and leaves at south. Okay, the traffic flow direction. And between the server and the data center, if between the remote place and the data center, north to south, and between the server within the data center, east to west. Okay, the major problem for this is the security inspection and filtering. What is the security inspection and filtering is, for example, if you have uploaded a photo or something, okay, so for backup reason, for other reasons, it will get automatically passed to other servers, okay, and it will be very tough for recalling or for analyzing or for security inspection to find out where it is really, to capture it, to check it out, okay. So normally for analyzing and filtering, okay, yes, of course, we'll be having logs and where uploaded, who uploaded, all these information generally. And we have zero trust. Yes, do not rely on perimeter security and continuous context-based authentication. We need it. And micro segmentation. Continuous context-based means that we're based on the IP address, based on the port number, location, all. And micro segmentation means single host zones. That is policies to single node, separate policies for single nodes. Okay, like it was if we can consider like that particular single node itself a single zone, like that. Okay, we have the secure switching and routing. Yeah, in this topic we will be checking out what are all the protocols and what we need to do really with the switching and the routing and the protocols. We have everything and what all the attacks can happen. That's what. Okay, man in the middle attacks. So man in the middle attack is a very important attack that happens with the network, where attacker can intercept your traffic, they can do modification to the communication, they can pass it on. Okay, and we have this on-path attack. Okay, so what is this really? This on-path attack is actually you can say both man in the middle attack or on-path attack is where a particular attacker will gain a position in between two hosts. Okay, it can be two hosts or it can be a gateway. Okay, and he can capture it. So a threat actor will do man in the middle attack. He would be needing this on path attack, means the traffic will go through him. He will be on the path for that attack to happen. Okay, and snooping is a technique we will maintain to avoid certain attack. What kind of attack? I'll explain you. We call it as DHCP snooping. Okay, and what is spoofing is stealing identity. Simply understand that stealing identity or imitating, or you can pretending as someone. Okay, so let me tell you. You have in here, one second, my bad, sorry, I got confused with the poisoning and spoofing. Okay, spoofing is simply, changing the identity. That's it. You can, if you go for MAC address cloning or spoofing, you will change the MAC address hardware interface address, but it is easy to change, but only temporary, not permanent. Whenever you restart your machine, it will get reset to original one. Okay, so whenever you do attacking or whenever you do working at that particular moment, you can go for spoofing attacks, but it will not longer move. So IP spoofing, MAC spoofing, okay, and location spoofing using proxies. So all works in the same manner. Okay, now we have here our poisoning. So this is what I got confused in here with the spoofing and poisoning. Okay, what is poisoning in here is, this is where that you will get, you will pretend that as someone. Okay, by using spoofed MAC address, you will do ARP poisoning. How? We'll take a scenario. We need 3 members to perform this particular ARP poisoning attack. Okay, by having this unsolicited ARP replies, we will poison the data by using spoofed MAC address. Okay, just ignore the technical terms. I'll let you know how this is happening. Okay, so we have 3 members. Okay, one at left, one at right, and I'm the middle, who's the attacker. Okay, so whatever the user 1 is going to share with 2, it goes normally in normal situation. But when I do ARP poisoning, because so what is the ARP will be having? ARP will be having who's the MAC address and who's holding the exact IP address and MAC address. That's how the ARP poisoning checks and it will deliver the packet. That's how your communication happens in normal case. But when I do this ARP poisoning, I will do spoof the MAC address and I will change the identity. Okay, ARP poisoning will do MAC address and IP spoofing. Okay, so what will happen whenever the user 1 shares something, it will go through me, means I will receive the packet. And if I want to forward it, then it will go. Otherwise, I will change anything and then I will give it to. Okay. And if the response comes from the user number 2 to 1, I will receive it and then I will pass it on. This is what the functionality of ARP poisoning. For all the man in the middle attacks, ARP poisoning is the basic one. Without ARP poisoning, you cannot do man in the middle attack clearly. Whatever can be the attacks, there are lots of attacks are there in the man in the middle attack. ARP poisoning, DHCP starvation attack, DNS poisoning, SSL stripping, there are too many attacks are there to perform in the man in the middle as a hacker. Okay, so you need to be in the middle to perform R poisoning. So you will just spoof, you will just tell him that you are the one, and it's the same here. You will just tell the other person that you are the one that you want to receive the packet. Okay, so normally when the packet comes, you will just share it. If it seems sensitive, you will keep it, or if you want to change something, you will change it and you will pass it. That's it with the R poisoning attackers. Then MAC flooding attack. What is MAC flooding attack is? We have something in switch that is CAM table. Okay, CAM table, content addressable memory table, that stores all our MAC addresses when we connect with the switch, and it stores whenever someone is dispatching the packet for us, and it will come exactly to our address, right? And when we do MAC flooding, it will completely flood the CAM table, okay, and it will change the switch into hub. So your switch will start working as hub. So what is the difference between hub and switch in here? That switch is having the IP address and the MAC address information. So whatever the packet that goes and comes, it goes according to the both the information, it will go to the concerned person. Okay, in case if the switch start acting as hub works just blindly, like in broadcast mode. It dispatch package to each and every node in the network. So that is why we stopped using hub, we started using switch. So if it is dispatching, if it is delivering the package to all the interfaces in switch, if it start acting as hub due to MAC flooding, so you can easily sniff it. Okay, that is what facilitates the sniffing through MAC flooding. Understand? Now, so the MAC spoofing and the MAC flooding is a very important thing in order to defeat this man in the middle attack, right? So to keep it up, to maintain that, to avoid man in the middle attack, we have to do this physical port security and MAC filtering. So we'll take the live example in here. You are using internet, okay, and you're sitting in a public Wi-Fi, okay, and I'm also sitting there in the public Wi-Fi. Okay, so you're going to browse something, okay, and how your packets will go, where it will go first. Your packets will go to gateway, right? Your packets will go to gateway first means the router. Then it will go outside of your network to the website or web server that you're using. Okay. So what attacker will do? Attacker is also on the same network. So what he will do? He will use tools to do ARP poisoning. So what he will do, he will send unsolicited ARP replies to poison the entries. Okay, means I will inform the gateway, okay, that I am the original user. That is, I'm sending you the request, and I will inform you that I am the gateway. So you just give the packet to me. Okay. So when you give the packet, I will get it, I will inspect it. If seems it's very sensitive, I will keep it, or I will steal something. Then I will pass it to the gateway. When gateway gives something, I will receive it. If I want to change something in it, I will change it. Otherwise, I'll give it. Okay. That's what ARP poisoning is. It is man in the middle attack. Okay. This is how man in the middle attack is being done. And you need ARP poisoning to carry out any other man in the middle attack. If you want to do DNS poisoning, if you want to do change anything, you have to carry out ARP poisoning first, then it is possible to carry out the other attacks. Okay. And path means it needs to be in the same network. That's what. If you are in the different segment, if you are in the different subnet, it will not work. Okay. So we have this physical port security. We can secure the switch hardware by physically disconnect any unused ports or disable unused ports via management interface. We have to do this on the switches physically. Okay. And you have to add MAC address limiting and filtering. Okay. The physical port security and switch port security and the MAC address limiting and filtering, actually, the MAC address limiting and filtering, I will avoid MAC spoofing. Okay. How? Normally in switch port, we will connect an Ethernet cable, right? And it will be connected with the computer. So whenever an interface gets connected, okay, all the information will be collected by the switch and the device. So when I do MAC address limiting for a particular interface, I will limit it to just 1 or 2. Okay. So when I do that, I will have the permission for the MACs. How many MAC address that I can permit? I will limit the MAC changes, how many times it can change. Okay, for a particular port. There are chances that if I just displace, if I change my particular node, particular computer, so definitely MAC will change. Okay, so you can have one or two, maximum two, that is advisable for the MAC changes. And if you don't have that, so many times attacker can do MAC spoofing. When he do MAC spoofing, so it will have issues that MAC addresses will get conflicted. So then normally the poisoning attack will happen. But if you have the switch port security, it will not happen. Only two MAC addresses, so automatically it will stop collecting the packets, or it will start dropping it. Okay, and the DHCP snooping is a technique. Okay, DHCP snooping, actually DHCP is a protocol that we all know that allows a server to assign IP addresses and everything, right? With the DHCP snooping, the DHCP messages from a particular port configured as trusted are only allowed. Okay, that is why we go for DHCP snooping, and the dynamic ARP inspection will be done on each with the DHCP snooping. We will do dynamic ARP inspection, which can be configured with the DHCP snooping. Along it will go. So what it will do, it will prevent a host attached to untrusted port. Okay, if there is any flooding happening, if there is any repeated packets that are receiving, if any port is untrusted, so the dynamic ARP inspection will prevent that particular host. Okay, so maybe the dynamic in the configuration of DHCP snooping, I have to check the ARP list, and then I have to trust the devices that are connected with particular ports. So if I see anything, maybe I will have a list of IP address. I know my network, so I will add it. So if any new user or anyone connects, they will get definitely a new IP. So that IP is not trusted in my DHCP pool. So definitely it will stop it. Okay. That's what with the physical port security and MAC filtering, how you can secure it. And we have this route security also, sources of routing tables. Okay, preventing route injection. Okay, so routing tables, that is responsible for how your data are getting transmitted or move everything. Okay, so route security on the internet, you can say it is very easy for the attacker to spoof any website. Okay, and an enterprise network, it is easy for them to lure any victim out of it. Okay, so we'll have firewalls, so proper routing is needed. So when the proper routing is needed, for example, I know you are using a proper site. Okay, and attacker know that I'm going to create an exact one, or I will deploy a similar one with the IP address one outside. So I will do it. But if I have proper routing, with proper route injection, with proper routing, I can easily stop that your request is moving out towards another IP. Okay, so source routing needs to be done, patch management, and router appliance hardening. This is actually hardening techniques that you need to carry out on routers. You have to apply patches for the routers, so you can keep it very safe. Okay, so we'll have the implement secure wireless network. Okay, so we'll go for a break. Okay, so we have the remaining topic, how to implement secure wireless infrastructure, what are the protocols that we have, and what we are really going to do with in properly implementing wireless security settings, how to install, configure, what we need to maintain and all. That's what we're going to cover in this particular topic. Okay, so we have this wireless network installation consideration. Yes, because a network architecture, a network without wireless is not, it's possible, but it is necessary that we all started using that Wi-Fi access point and wireless devices in the network, right? And we can say that it is very vulnerable to Wi-Fi hacking and multiple rogue point attacks, and multiple attacks are very ongoing in recent times, right? So ensuring maximum availability from legitimate access point is very important, because rogue access points are large in number, and attackers' main motto to crack any Wi-Fi's or to trick any user to connect with your Wi-Fi, instead connecting with your Wi-Fi, they lure people to connect with their Wi-Fi by deploying a rogue access point. Okay, so we'll discuss about that everything. And we have wireless access point placement first of all. So of course we have the wireless access points which forwards the traffic to and fro from the wired switched network. Okay, so you can have the access point is normally that one with a switch network. We can call it as access point. If we use it in the wireless, we have wireless access point. Okay, so we have the service set identifier SSID, that is your Wi-Fi name, and BSSID, basic service set identifier. That is your access point's MAC address. Okay, and we have different frequency bands and channels in here, 2.45 gigahertz bands, and you'll face co-channel interference. So what is this co-channel interference? When you have two wireless access points in the close proximity region, okay, that uses the same channel for communication. So they compete for the better bandwidth with that particular channel. Okay, so it will get collided and have to be retransmitted. So there will be a lot of losses will happen. So it is better to have a clear space between two wireless access point. Yes, of course, it will get intercept. It will both will get collide. But if it is lower or if it is lesser, that would be good. Okay, and adjacent channel interference. Okay, so what is this? The wireless access point runs in the channels sometimes have only 5 megahertz spacing, but Wi-Fi requires sometimes more than that in the channel space particularly. So that channel is the one where it connects, where it disposes packets, everything. You have the channel, you have bandwidth, you have data beacons that you are sharing, everything we have in the wireless. Like when we have Wi-Fi hacking and all, so you have that all the necessary information about everything. Okay, so when the channels selected for this particular wireless access point are not clearly spaced, the interference will happen like we have seen in the co-channel interference. Okay, and if the two access point is within the range of one another, okay, between the channels, especially one up to actually there is 13 channel numbers, 1 to 13. So if the channel number is between 1 to 6, they will not overlap much. Okay, so placing a wireless access point is very, very important. Adjacent channel interference should not be like it is not. Co-channel should not be there. Adjacent channel interference can be ignored if it is using a channel number between 1 to 3. Okay, and we have site surveys and heat maps. What is this one is? Yeah, we've been discussing about placing a wireless access point in a proper coverage, proper place where it should not get into interference and all. So the site survey and heat maps are very important. So we'll get an architectural plan for placing the wireless access point. So we can use some Wi-Fi analyzer that shows where you can place your Wi-Fi access point. So the it will generate, the Wi-Fi analyzers will generate the heat maps that will plot the signal strength. High will have the red signal, the high signal strengths will be displayed as red and low will be green or blue. Okay, so the heat map will be very, very helpful in designing your architectural plan for wireless. And channel layout shows the overlapping usage. So you'll have the channel layout that will let you know that both the Wi-Fi access point is overlapping or what, everything. Okay, and the controller and access point security. So configuration of multiple WAP, wireless access points. Okay, and hardware and software controllers. For configuration of wireless access point, fat versus thin wireless access point. Let me tell you. So there are hardware and software controllers available. Controllers are used to configure your wireless access point. Okay, the fat one is you would be having controllers for configuring your wireless access point. Thin wireless access points don't need the controllers to configure your wireless access point. And of course, physical security is mandatory, where you are placing your Wi-Fi router, okay, and who's having access to it, and managing the interfaces, how we're going to do it. Okay, and we are going to discuss about in here the encryption techniques that we have so far. So we have WPA, WPA2 and WPA3. Okay, so we started with WPA1 version 1 and we are using WPA2 in larger number, and we use WPA3. Okay, it is not fully rolled out completely. Most of the organizations and most of the home routers are using WPA2 only. So we have this different encryption standard. In WPA1, we were using RC4 encryption with temporal key integrity protocol. In Wi-Fi WPA2, we are using advanced encryption standard, okay, that replaced RC4 with the CCMP, cipher blockchaining messages and authentication code. Okay, and in WPA3, it uses simultaneous authentication of equals and it is an enhanced one, updated cryptography, management protection frames, everything. Then what is the main difference between all these three? WPA 3 is not fully rolled out. We'll talk about WPA 1 and WPA 2. WPA 1 used the centralized authentication system. Means if you want to get connected with the network, it would be giving you an IP address, or it will authenticate you, it will accept your request by using a centralized authentication system, a server. Okay. But it was not feasible all the time to meet the clients by using a common authentication system. Okay. That is why we moved to WPA 2, where it was normal with just simple four-way handshake. We simply get authenticated with the Wi-Fi routers with simple four-way handshake. Okay. So how this WPA 2 is really working? You will use the passphrase to connect, that you know. What about this four-way handshake, and what is this PMK is used to derive session keys? The PMK is to derive session key means when you connected, when you start connecting, right? When you start having conversation, this pairwise master key is used to derive the session that you got established with the access point. Okay. So what is this four-way handshake is? Okay, simply we can easily, very easily we can understand this. You have your computer and you have your mobile phone, right? When you have the Wi-Fi button, when you just click on the Wi-Fi button, you can see lot of wireless devices around you, right? That is your first way of handshake that comes from the router. When you can see the list of access points, when you click on a particular one, right, that you are making the second way of handshake that you want to connect with it. Okay. Then if it is password protected, it will ask you the third way of handshake. Okay. Message of authentication will be received from the router. So it will ask you for the password. That's your third way of handshake. When you enter the password, when you click on connect, that's your fourth way of handshake. If the password is right, it will let you connect to it. Otherwise, it will go again back to the third step. Again, it will ask you to enter the password. Okay. That is what we have in here about the four-way handshake. Okay. So in WPA 3, they just replace the four-way handshake with simultaneous authentication of equals protocol, SAE. That's an advanced protocol. Okay. Still study is going on with this protocol. Lots of vulnerabilities also has been discovered with this WPA 3. Okay. And it is using Dragonfly handshake as well. And this particular SAE used the Dragonfly handshake, which is basically a Diffie-Hellman over elliptic curve key agreement. The protocol that we have discussed yesterday, right? It was using that one. So it would be a difficult job for us to crack WPA 3, but WPA 2 can be easily cracked without having any question. WPA, we don't have to ask about it. And this one, this is simply, we can say, it's just there, but we don't want to use it. It needs to be disabled in your router itself. There is a push button at the back of your router, right? So that helps you to connect to your router. WPS, push button, Wi-Fi protected setup. It comes with 6-digit Wi-Fi WPS pin. Okay, a password auto configuration of your access point and clients. So when you just click on it, it will automatically take, even mobile phones also, few mobile phones also have that option, connect by WPS pin. So when you do click on it, when you click the WPS button on the router also at the same time, you can easily connect with it. Okay. And it is very easy to brute force vulnerability in passcode algorithm, because it is just a 6-digit code. You cannot use alpha characters or anything. You can simply go with numeric numbers. That is also 6 digits. So combinations are very less. It can be easily brute force. Okay. And this access point may support lockout to, you have to disable this. Like you can use the lockout functionality to mitigate the brute force actions, but it is good if you disable the WPS fully. You have, when you just log into your router, your home router also, you have this option. Just open your gateway and you just type in your password. You have the WPS option. Make sure it is disabled. And even if you press the button also, it will not let anyone to connect. Okay. And make sure the access point firmware is up to date. And it is easy connect and device provisioning protocol it is using, but no one is using this one for connect these days. And we have this open authentication and captive portals. What is this? You can see the open Wi-Fi. That is what open authentication without any authentication or encryption. That one is that. And you can have secondary authentication via captive portal or splash page. That is when you connect with your Wi-Fi, when you connect your Wi-Fi with airport or public metro stations and all, you'll have that captive portal that opens in the browser. It'll ask you to sign up using mobile numbers, or it'll ask you to sign up using email ID and they will give you a time limit of 7 minutes, 10 minutes, and then you have to re-log in it. That is one. Okay, you can use this, but it is always good to use two authentication, not only the secondary authentication. Okay, and everything sent over that link can be snooped. Using secure protocols for confidential data, you have to use HTTPS, secure IMAP, FTPS. You have to use it when you are using the open authentication and captive portals, and use VPN also to create a secure tunnel, because there is no authentication at all. Anyone can get into it, and bypassing captive portal is not a big deal. So hackers can easily connect to it, and you cannot complain, or you cannot go anywhere also, because you agree for when you're connecting to open network, it is just like a unwritten agreement that you agree for any consequences that you're going to face. Okay, so use a VPN and Wi-Fi enhanced open. So what is this Wi-Fi enhanced open called? The WPA 3 can implement a mode called Wi-Fi enhanced open, which uses wireless encryption, opportunistic wireless encryption. Okay, that uses Dragonfly and all. So this one is for like that relates with the WPA. Sure, then we have the authentication systems that we have in here. We can use extensible authentication system. You can choose it inside your router configuration panel over the wireless, and you can use radius also. But if you want to use radius, definitely you'd be having the Active Directory and other server management. Then you will use user credential to generate session encryption key to start with. Okay. Then we have this extensible authentication protocol designed to provide interoperability security devices and software. Especially for like interoperability, you can connect with any device. There won't be any. See, if your routers are using Unix or Linux firmwares, so it won't be asking you to Linux or Unix machine to connect. So there will be interoperability, right? Transport layer security to authenticate via the device, and both server and supplicant must have the certificate. Mutual authentication is very important. Okay. And the attacks, yes. So this is very important. You will have question from this particular evil twin part in your exam. Okay, what will be that question? I'll explain. So rogue access point. So we are all using our Wi-Fi, and we are very sure that our Wi-Fi password is very strong and no one can crack it. Okay, and what is this rogue access point we have? It is a exactly similar access point that looks like the legitimate one, with the same SSID, same BSSID, and with the same internet connection, everything. Okay, we can create it easily. Okay, and with that, what attackers can do? Attackers can disable the devices very easily. Okay, in here they have added in here, it will be used to do for troubleshooting, and they can disable unused devices and interfaces to check what is happening. But attacks can be done using this particular rogue access point by creating DOS attacks on the available devices. Okay, if I create a rogue access point, the scenario is I won't be connecting to your network. Instead, I'll create a DOS attack on your Wi-Fi router, jamming activity. So you will not be able to use your router. So when you just open the network access points around you, so you can see that you will try to connect with my network, means my router. Okay, that is what called as evil twin. Okay, where I will masquerade as a legitimate access point. I will use the same similar SSID, and I will capture the password from you, and I will use it as you on your original routers. So Wi-Fi hacking can be done in different methods. Directly, I will try to crack once, or if it is not possible, if you are using very strong password, then I'll go for evil twin, because out of 100 employees or out of 100 people, definitely at least one will be not aware of these kind of attacks. So they will give away the password for me easily, straight away. Password will be received straight away. Okay, then Wi-Fi analyzers will be used to understand what's happening. You can see the Wi-Fi analyzer that we have seen to get the maps, heat maps and all. So to check the bandwidth, signal strength, okay, everything we can use the Wi-Fi analyzer. And disassociation and replay attacks are there. That is, disassociation means deauthentication attack. Okay, means you can create jamming activity where attacker will send spoofed deauthentication packet. Everyone will get disconnected, or I can choose a particular victim to get disconnected. Okay, and that will help me to assess the other attacks like evil twin attack. Okay, and what is this one? This disassociation attack means I will just disconnect it. Okay, and I won't be using it for any other further activities. That is what disassociation. Very small difference. If I use the victim for other attacks, that would be deauthentication. And if I just disassociate him, that will be the disassociation attack. And we have management frame protection with according to the standards. We have the initialization vectors actually. What is this initialization vectors actually? See, when we try to make handshake, we'll be interchanging the initialization vector between the server and the router and the client. Okay. When we do Wi-Fi hacking, we will generate packets to strip that initialization vectors because that indicates the authentication information. When you do try to connect, the initialization vectors will get traversed during the authentication. So attackers will also do the same to reveal it, so they can do key reinstallation, crack attacks to crack the Wi-Fi. So they can replay that, so they can easily get into your Wi-Fi networks. Got it? Then we have jamming attacks. So in jamming attacks, environmental versus malicious interference. Yes. Normally, if you have interferences, there are chances that your Wi-Fi will not work normally as a usual one. But if you are in an attacker zone, he can carry it out with malicious interferences also. Okay. And we have jamming attacks, denial of service, simple. And to promote evil twin, he can perform it. And to identify how we can identify from where it is happening, by what's the reason that this particular interference is happening, from where it is happening. So we have to use spectrum analyzer to locate the source, from where this particular interference is coming. Okay. So how I will just add an extra point to this. How an attacker or how a hacker will deauthenticate you, or how an attacker will create jamming activity, or how this thing is happening. Okay, so this I know. I will capture the packet first. I'll get to know who are all connected to the Wi-Fi first thing as an attacker. Then I'll pick up my victim. I'll choose my victim. Then I will send spoofed deauthentication packet, or it is also called as packet injection activity. Okay, so I will inject packets, then I will deauthenticate that particular user. Okay, so then I told you I will capture the initialization vector, and I will try to replay it, and how I will use it, right? So for those points, when I do deauthenticate him, right, eventually you will automatically try to reconnect. We have that option, we have that option, connect automatically, right? We have that option, connect automatically. So if you have that option enabled by default, automatically your access point will try to reconnect. Okay. Have you noticed that your Wi-Fi access point will never ask you to enter the password for the second time until you forget the network, unless you forget the network, right? Means the WPA2 encryption, or this particular encryption wireless technique, is having pre-shared key authentication. That is PSK, pre-shared key authentication, means whenever you just connect for once with the right password, that the keys got shared successfully between the machine. Okay, so for the next time when you try to connect, it won't ask you for the password. That is also an advantage for the hackers. So when you are intercepting already, you did DOS attack, and when he is trying to connect, you can easily retrieve the keys, and you can perform the replay attack, or you can crack the password easily. We can easily, when the deauthentication happen, we will try to capture the package, and we can easily crack it. So there are tools we can use for Wi-Fi hacking and all. So that's a different part, not with this. Okay, so we have the load balancers also. What we have the load balancers. So for a proper network design, still we haven't covered about the appliances for network security. We are just making a proper network design only. So we need load balancers also, along with routers, switches, and the other devices. So how to do it? What is the functionality of load balancer? That's what we're going to cover in this topic. So leverage the bandwidth from compromised hosts or networks. That is, handlers form command and control network. Attackers will do it. They will form a command and control network. They will carry out DDoS attack against your network. So that is the place where you would be needing load balancers. Why? If someone is attacking, you have a server, and your server is good, healthy, configured server, but how long it can hold, right? So compromised hosts will be used as bots that can run automated script. So what I will do, Tomorrow I will give you a software. Okay, all 13 of you are you going to install it. Okay, and I'm mentioning that it is having the practice question with you. Okay, it is having the practice question with it, so you just practice it. You think like when you will just open it for next 1 month, you'll open it, you will read 10 questions, you will close it, you'll open it, you'll read 10 questions, you'll close it. This will go on. But if it is having bot with it, you won't be having idea that bot is having some automated scripts running, and it will do attack on the victim, maybe anyone, any other. So all 13 will become botnet for me. So coordinated by me with the command and controls network as a botnet, you'll be carrying out distributed denial of service attack on someone. Okay, so I will do overwhelm with superior bandwidth, consume the resources with spoofed session requests, multiple packets. I will keep on sending until that the victim machine cannot hold it. So that is what called as denial of service attack. Simply means that it cannot take it more. Denial of service, when I do it with 13 systems, that is distributed denial of service. So to avoid that, I need load balancers. To avoid that, I need load balancers. So they're just explaining in here about the different types of attacks. Okay, distribution and all. Then we'll go for load balancers. Okay, so we have this application and OT level attacks and all. So distributed reflection DOS attack. Okay, so what is this distribution reflection DOS is? It is an amplification of sync flood attack. Okay, before we proceed with the sync flood and all, let me ask you, do you guys know what is sync flag is, right? Sync packet is, that is mandatory for creating a connection using TCP handshake that we know, right? Three-way handshake. The TCP header uses sync flag, the first flag that it initiates the connection. Okay, so we will be using that packet only, nothing big, right? So we will use sync flood attack. A threat actor means a hacker will spoof the victim's IP address and he will attempt to open connection with multiple servers. Means what? Example is, I am the attacker, you 13 member or servers. Everyone is having a server. Now I have a victim with me. I'm going to attack him. Okay. Now what I will do, I will spoof my IP as his IP. I will spoof my IP as his IP. And I'm going to send the sync flag. So when I send sync flag to someone, sync packet to someone, what happens next? Of course, the other end machine will reply me with sync plus acknowledgement, right? So when it is going to send me sync plus acknowledgement responses, it will not send me. Okay, it will not send me. It will send the original IP because I just spoofed it. The return packet will go to the original victim, not me. So eventually, unlimited number of packets will go end up on the victim's machine. That is what distributed reflection DOS or DRDOS or amplified sync flood attack is. Means distributed reflected DOS will be carried out by amplified sync flood attack. Okay, multiple responses will be received from the servers to hit on a particular victim. Okay, then we have application attacks. What is the application attacks? By having bogus DNS queries, NTP queries, direct the responses at victim. Okay, queries can be constructed to generate large response packets. Now, let me tell you in this way how HTTP request will be generated by the attacker. When it reaches the application server, the connection needs to be established properly. Okay, so you can do converse with the application. It happens in the application layer. But attacker, what he will do, create only half of the request, partial request. Okay, so when I do create partial request, it will send multiple, means it will be waiting for the full established connection. Okay, I will create multiple queries to generate large amount of packets. It will be waiting for the connection and it won't be able to respond to it. Okay, that is what application level DOS attack is. You can do in a different manner also. You will just do the same by attacking an application by creating the multiple requests by using bogus DNS. If I want to do attack a DNS, I will spoof my IP as DNS and I will create multiple requests to the web server and I will redirect the responses to the DNS or the other victim. Okay, these kind of attacks I can do with application. So OT is there, operational technology networks. So I'm not sure like how many of you heard about it, operation technology. There is no proper course for it. There is no proper, guidelines for it. Few organizations are doing this OT security, operational technology security. If you have OT networks, that is ICS, industrial control systems. When you have industrial control systems, the factories, machineries, okay, CNC machines, so the embedded systems, all these machines are considered as OT. So all these OT networks are also subjected to DOS attacks, okay, and it can be more vulnerable to miscrafted packets than computing host, because there are no skilled professionals, especially information security or cyber security skilled professionals to work on OT to secure these kind of attacks. So they are all major targets now, but the protocols are completely different. If you are starting your career and you will be starting as new, okay, but it'll be a huge demand. There will be a huge demand in future, okay. Then distributed denial of service attack mitigation. Now here we're going to discuss about the load balancing and everything. So attacks uses spoofed addresses to make them hard to block, okay. And the one option we can do is we have to drop the traffic to protect the other host in the routing domain itself, or sometimes DOS traffics get dropped in the internet service provider level itself, okay. Or you can have this black hole and sinkhole routing. That is, if you can see multiple requests, it will get dropped before it enters, okay. Or sinkhole routing means it will route to the valid IP where we have the load balancer, okay. Let me give you a clear live example for that. Cloud DDoS mitigation services. What is that? We are all using websites, web servers. We used to serve. You might have seen that Cloudflare protection is enabled. Cloudflare DDoS protection is enabled, right? So how this is working, how the Cloudflare DDoS protection is working. When we create multiple requests, it goes to the very nearby Cloudflare server. Okay, for example, if I'm attacking google.com, okay, so my multiple requests will go to google.com. In case Google has Cloudflare protection, okay, for example, I cannot originate or I cannot perform my DOS attack or DDoS attack from one machine. If I do DOS attack from one machine, definitely with the resources, with the machines Google have, it is not a big deal to attack from a single machine. So I need at least 100 or 200, maybe thousands of compromised computers to carry out my DDoS attack. So am I going to have this 1,000 computers? No, I'm going to use other 1,000 computers all around the globe. So somehow I've sent my bot, I've compromised their system, and it is going to carry out the attack on the backend. Okay. So what's going to happen when the attack is going to happen on the backend? This attacks the multiple packets, multiple requests that is going to leave from the origin goes to nearby Cloudflare. Okay, the Cloudflare uses same IP. Okay, same IP, spoofed IP on their load balancers. Okay, so if I do attack from India, it will go to Indian server somewhere. If someone is doing from Middle East, it will go then to the nearby server. Australian, it will go to nearby server. American, it will go to the nearby server. So no attack will be established with complete full force. So your DDoS attack got defeated by Cloudflare in the middle. Whatever you packet you would send, there will be multiple mitigation techniques will be there. Dropping the packets at ISP, or deflecting. Okay, they may have big load balancer. Before that, Cloudflare itself defeat our DDoS attack like this. Cloud DDoS mitigation services we have. That's how we can beat it. Got it? Then we have load balancing. So distributed the request across the pool of servers, like we discussed. Layer 4 load balancer, layer 7 load balancer that contains switch. Okay, you can see in here. So if the load balancer is there, you have the web server, multiple web server, and the multiple request comes, it will just divide it to different web servers. Okay, and we have this scheduling, and you should have fewest existing connection round robin. Okay, and we have heartbeat and health checks, waiting. Okay, so let's discuss about all this one by one. Okay, so what is this scheduling? First of all, scheduling algorithm is the code and the metrics or the measurement, you can say, that determines which node is selected for processing each incoming traffic. How are we going to do it? Okay, The simplest one for doing that is this round robin for processing each request. Okay, means this just picks up the next node. Okay, the other methods we have in here, picking up the node with the fewest connection. Okay, best response time, which server is having the best response time, which server is having very fewer connection already. Okay, all this. And we have other methods also like weighted. Okay, it will use the administrator parameter or dynamic load information from the access control list, what's happening. Based on that, it will do schedule the packets, traffic, where it should go. Okay. And the load balancers must use this heartbeat and health checks for sure. That is, you can say, to verify whether the each node is available under the load or not. Okay. Is it active or not? Is it receiving already or not? So once you start checking the fewest existing connection, you will get to know that all this is under load or not and all. But still, we have to verify that separately also. Okay. Source IP affinity, session persistence. How is the session persistence and all? Okay. How stable it is? We need to verify that. Got it? Then we have the clustering. Okay. What is clustering? Configuring the nodes for failover. That is multiple redundant processing nodes that share the data with one another to accept the connection. The clustering will allow that. Okay. So what is failover is in here? Actually, it provides a redundancy for our connectivity. How? If any one of the nodes in the cluster stops working, cluster means a bunch of devices, bunch of load balancers. Okay. So one stops working, connections can fail over to a other working node. Okay. We have to configure it. In case if anything fails, we have to drop everything. Okay. We don't want any other to get affected. Okay. So to the clients, the cluster will more or less looks like a single server only. So it is attacking on single. If that is down, it will not be able to attack. So it will show that there is no particular alive active host. So packet will get dropped in the middle. So DOS attack will not be a successful one. Okay. Common address redundancy protocol will be used for virtual IP and active and passive. I think it is repeated in here. This point is misplaced. Okay. Then we have the application clustering that provides stateful fault tolerance. Okay. So what is this application clustering is? Very commonly used to provide fault tolerant application services. That is, if the application server suffers a fault in the middle of a session, when something is going on, okay, the session state data will lost in the middle, right? So the application clustering allows the server in the cluster to communicate the session information to one another. That's what application clustering is. In case if anything happens in the middle, this will act as a backup, okay, for one instance, not for a long time, okay, until the new server or until something kicks in. So it will give an extra hand. For clustering, we can have multiple load balancers in the middle so that we can spoof sometimes, so that we can take backup sometimes, okay, for that reason. And we have quality of service. Yes. So compared to best effort, first in, first out, okay, and best bandwidth would be needed, latency and jitter, we have to maintain that, traffic marking, okay, and traffic policing, then denial of service and trust boundaries for traffic marking. So ensure the bandwidth for management and security monitoring the traffic. Okay. So what is this diff serve? Okay. So what is this diff serve and all? Particular Ethernet header that will indicate the packet should be treated as priority. Okay. With the traffic. The traffic should be reached properly. The traffic should be received properly, but not all the traffic. Okay. It transmits the frame to the switch. Everything will be happening. Okay. But it needs to be properly monitored. Okay. With traffic policing, then up to only the trusted boundaries for the traffic marking. Because if we receive more, we have to come to an idea that it is under attack, whether we need to take steps according to, we are going to do mitigate it, or we are going to do deflect the traffic, all this. So that is what we have learned, like how it is done with round robin and the scheduling and all. Okay. So these devices needs to be implemented in our, implementing secure network designs. So we have to do it in order to have a secure network structure. Okay. Sure. I think we have lab also for this. Okay. So we're going to try to implement a secure network design in here. In this part 2, you will configure DHCP security settings and IP address reservation, auditing logs and all. Let's see one by one. We'll request server certificate first. Okay. From the IAS manager. Okay. Server certificates. Got it. We have to create domain certificate. We have done it already, right? We've tried it. We're going to do the same only. Let's try. Okay. Common name. Organization. Organization unit. City. State. Okay. Friendly name. Finish. Okay. So we've created our own certificate. Like yesterday, it was not working for domain certificate. We've created self-signed one, but today it worked good. Okay. So we're going to configure. We have a site running, default website. Okay. And click on edit bindings. Got it. We will add, click on HTTPS and the IP address. We'll just type the host name. Okay. From the SSL certificate, we will use it. Okay. Automatically took 443. Good. Click on OK. Yes, I think it is done. Okay. We have added it. Okay. They have just removed it. We'll remove that also, but it won't create conflict. Let me restart it. If we wanted the server to be running properly, I restarted it. Yesterday it was not working fine. Okay, now we're going to configure the authentication policy. Okay, select the default website node. Then we have to open the authentication applet, select anonymous authentication and then disable it. And we have the basic authentication, we have to enable it. Okay, for the site we have done it fine. And we will move to Kali machine. Okay, they are just enabling a site security in here, nothing much. Okay, so we have added the certificate. Very fine. HTTP is not working. HTTP yes is working. Okay, great. So we added the basic authentication and it's working fine. That's what the point is. That's what they want us to do it, and we'll just use the normal credential that we have to verify really it's working. The normal machine password. Okay, it is working. Great. Now we have the DHCP security in here. We'll go to MS machine. It's already on. So go to tools, go to DHCP. Okay, then we'll select the MS1 domain. Right click on it. What is it? Okay, we have to choose IPv4 already. That, it's really confusing as like they are asking us to do the task in the middle. Okay, so we'll select the IPv4. We'll add a new scope. Okay, name special project. Great. Do we need a description? No need. Start IP address. We are configuring the DHCP now. End IP. Okay. Subnet mask. Okay. Okay. Lease duration, nothing. Configure DHCP options. Yes, I want to configure these options now. Then the IP address. It is for router. Okay, add it. Yes. Okay. Click next. Yes, I want to do it. Finish it. Okay, we have added the IPv4 range and added the router IP address, everything. So select the scope for this special project and then display the statistics. Why it's not showing? It is disabled. Is it any window that is running? Yes, in here we have. Okay, in use it is available 100%. Total addresses 11 we have allotted. Okay, how many total addresses are available? I think 11. Is it the right one? Yes. Okay, now we're going to do one thing. Okay, select engine reservation in the left hand pan. Okay, it is not having any reservations. Okay, we have it. I just checking the other one. Okay, properties, MAC address, copy it, cancel it. I couldn't see that LX1. There is no LX1 CentOS reservation. You see something? There is Kali only. This is the one we were checking, but okay, this belongs to LX1 only, so they're asking to delete it. We'll delete this. Okay. Okay. This is the special project, right? Yes. Add now the new reservation. And here we'll add reservation name, IP address, MAC address that we've copied, description, special project consultant, and support types, everything is same. Click on add, then we close it. I think it is added from the other pool to this pool that we have created now successfully. Now select allow node. You have to add new filter. What filters? Click on allow. New filter. Okay, we have to paste the MAC address here as well, and we will be giving the name. Okay, then add it, close it. Okay, we added the filter that we've configured the pool and we have created the IP address, everything. Okay, enable allow list. You need to verify it is really allowed or not. First of all, we maximize it. Enable. Okay, it is enabled now. Great. So have we done all the steps? Great. So that's the end of this lab. We have configured a DHCP server with only the IP address that we want to use, and we've just misplaced means we have just replaced one particular IP address from one different pool to another pool. That pool was created by us especially for this security purpose, and we have allotted the domain also with that. So if someone is trying to connect with that particular DHCP with that particular wireless, so they will be allotted with this IP address only. No more IP address will not be entertained, and we have given the range for only 11 IP, so it's not big range, so it could be very good. But if you're going for the bigger level networks and all, right, the DHCP snooping should be done properly in switch and the routers. We have done it in here, okay, in an isolated network environment or local environment when we are using it. But if we want to use it in the network, sorry, in the device based security, so we have to go for DHCP snooping, okay, in the routers and the switches. Then we'll be having higher security to avoid man in the middle attacks and all the different various other kind of attacks that attackers can carry out. Specifically, like man in the middle attack will be more dangerous, and DHCP starvation attack will happen, okay. But in this case, when with the configuration that we have done now, right, this will definitely avoid the DHCP starvation attackers. So what is DHCP starvation attack will do? DHCP starvation attack will get or will use all the available IP address in the list, and it will make the DHCP unavailable for the available users, okay. So that's what the DHCP starvation attack is, and it will not going to happen. Just for practice, we used only 11 IP address. And yeah, of course, for DHCP starvation attack also we'll be doing DHCP snooping also only. So that's a one all in all security measure that you can take, port security and all, to avoid man in the middle attacks. Okay, so that's it for this particular session.